We usually perceive the universe as a collection of separate objects, but the mathematics of reality reveals a hierarchy of tension resolution engines. Modern science typically divides physics, cognitive science, and sociology into separate silos. This fragmentation obscures the isomorphic architecture that connects the physical behavior of subatomic particles to the behavior of human civilizations. Identifying this shared geometry requires the unification of three specific frameworks: Penrose and Hameroff's ORC-OR theory for the quantum substrate, Carl Friston's free energy principle for cognitive thermodynamics, and Bowen family systems theory for network topology. To map the mechanics of consciousness and the logic of societal collapse, we must track how information scales across three domains: the micro, the meso, and the macro. The microscale defines the foundational unit of processing, the isolated node, whether that is a single quantum qubit or an individual human mind. The mesoscale defines the network of action, detailing how these individual nodes link together to distribute stress and compute a shared reality. Biological systems operate as scale-invariant algorithms. At every level, they utilize the same mechanical principles to maintain structural coherence against the universe's baseline entropy. At the microscale, the basic processing unit of consciousness resides within the geometry of the neuron. Analytically, the ORC-OR model identifies neural microtubules as fractal time crystals. Tubulin proteins act as topological qubits, maintaining information through self-similar resonance. Delocalized electrons maintain quantum superpositions via unharmonic resonance. This nests quantum beating within a classical frame, isolating signal from noise. This same isolation of signal from noise defines the cognitive level through the lens of thermodynamics. Carl Friston's free energy principle states that the prime directive of a biological system is Bayesian inference. The system must minimize variational free energy, denoted as F, to prevent its own structural decay. A predictive brain limits informational entropy by continuously aligning its internal world model, the generative prior, with the incoming sensory data of the variational posterior. Human psychology follows this exact thermodynamic process, as described in Bowen family systems theory. The concept of intrapsychic differentiation is the psychological equivalent of minimizing free energy. It measures the capacity to distinguish between intellectual and emotional functioning. A highly differentiated individual maintains a solid I position. This allows them to separate rational calculation from autonomic emotional reactivity, even when the surrounding environment is under high stress. At the microscale, a successful node, whether a tubulin protein, a predictive brain, or a human psyche, survives by keeping its internal signal rigorously separated from environmental noise. Since a single node has limited processing capacity, it must network with others to manage systemic tension without becoming overwhelmed. In the ORC-OR model, quantum states expand beyond the boundaries of a single neuron to form a larger computational unit. Quantum tunneling across dendritic gap junctions spreads macroscopic coherence across thousands of neurons, creating 40 Hz gamma synchrony. Through active inference, this synchronized network resolves the gap between prediction and reality by either updating internal perception or altering the external environment. The algorithm manages this through precision weighting, where the network decides whether to trust external sensory data or rely on its own internal world model to maintain stability. This mirrors human social triangulation. A two-person system is inherently unstable under stress. It must recruit a third node to redistribute the allostatic load. Under high tension, an emotional dyad cannot vent entropy effectively. It requires a third party to provide an alternate pathway for the discharge of anxiety. Anxiety is redistributed across a relational network through these interlocking triangles. The more triangles involved, the more the total stress is shared. Differentiated nodes within these triangles act as stabilizers. By remaining non-reactive, they prevent the automatic transmission of anxiety and maintain the network's computational flexibility. The mesoscale exists specifically to distribute thermodynamic and psychological loads that a single node cannot process alone. When the aggregate stress on a macro network exceeds its total capacity to process it, the system reaches the threshold of collapse. ORC-OR identifies this macro limit through the geometry of spacetime itself. Objective reduction occurs when the gravitational self-energy of a superposed mass reaches a specific threshold relative to its coherence time. At this Planck scale limit, the quantum state spontaneously collapses into a definite classical state. At the cognitive level, this physical collapse corresponds to a failure of the free energy principle. When a system can no longer minimize its variational free energy, its Markov blanket dissolves. The system loses its structural integrity and its ability to predict environmental regularities. This boundary is quantified in Bowen's power law. It balances the biological cost of differentiation against systemic stress. Because the differentiation gap uses a power law exponent, a wide gap means even linear increases in systemic anxiety cause exponential spikes in biological cost. Once the chronic collective anxiety overwhelms the network's aggregate capacity to pay this biological cost, the system undergoes a macroscopic phase transition. Societal regression begins. The network abandons complex active inference and regresses to primitive, binary, fusion-oriented processing. This creates a self-reinforcing cycle. Lower differentiation spikes threat sensitivity, which increases systemic anxiety, which further degrades the capacity for differentiated response. This regression is a topological shift to phylogenetically earlier behavioral patterns, characterized by tribal identification and emotional reactivity. Because this process follows the mathematical power law, societal collapse occurs as a predictable phase transition when the network hits its thermodynamic limit. Synthesizing these three domains reveals a shared mathematical identity. At the quantum scale, objective reduction resolves superposition point when gravitational self-energy hits Planck's constant. Cognitively, the brain minimizes informational entropy to maintain its boundary. Socially, systems manage allostatic load to avoid the collapse of autonomous thinking. Physics, psychology, and sociology are different scales of the same tension resolution geometry. Intelligence, in this framework, measures a system's capacity to maintain its structural coherence and computational complexity while under environmental pressure. This capacity, differentiation, determines whether a node remains an active processing agent or becomes a passive bearer of systemic tension. Addressing modern systemic crises requires a scale-invariant approach that accounts for the network topology governing human interaction. From the subatomic collapse of a wave function to the survival of a global civilization, biological life is a system that actively manages its own internal tension to avoid dissolving into the surrounding environment.